right, ladies and gentlemen, we're going to take a look at lesson 3.8, which is notes, rates, ratios, and percents. So you're going to be able to use those. We're going to do some practice and then take a look at how we identify and use those in real-world problems. A ratio is just a comparison of two values. So we can compare A to B, and so we'll see ratios written this way. We can compare boys to girls, and we can see it written that way. And we can compare football players to volleyball players. So there's three different ways we can write our ratios. But if we're talking about rates, if A and B are two quantities, but they're measured in different units, that's what it means to be a rate compared to a ratio. We have different units. So like in the examples here, boys and girls are the same units because they're human beings. Football players to volleyball players, we can consider those the same units because they're all athletes. But if we're comparing different units, then the rate of A per B is written as A over B. We're going to write that as a fraction. Unit rate is a rate per one given unit. All right. So often we find this in terms of price. So we're finding like the price for one ticket, the price for one shirt. So let's take a look. It says find the unit rate. It says you have $67.50 for 3 concert tickets. To find the unit rate, you're finding the cost for one ticket. And so most of you are pretty quick and you know to divide. Well, here's why. We're going to write that as a rate. $67.50 divided by the 3 tickets. If we write it as a rate, we can see that it means division. So I'm going to do exactly what it says. $67.50 divided by 3 is $22.50. What we're really working on here again, guys, is the labeling. So it's $22.50 per ticket. We use that fraction line, that division line to imply the word per. Find the unit rate. You've got 32 ounces for 4 servings. So we have 32 ounces for 4 servings. Once again, it means to divide with that fraction line. So we have 8 ounces per 1 serving. All right, so that's what our unit rates are going to look like. So let's take a look at an example of how we can use that. You recorded your car mileage and gasoline use for 2 months. So you apparently had to get gas 5 times. Estimate the number of miles you can drive on a full 18-gallon tank of gas. So how can we do this? Well, what we're going to do is find a unit rate. That's what we're going to do. We're going to figure out how many miles per 1 gallon. And then once we know that, we can multiply by the 18-gallon full tank of gas. So how are we going to do this with this information? Well, there's a couple of different ways. One way I like to do is I like to think of it in terms of an average. Okay, so I'm going to add up all my miles and then divide by 5. I'm going to add up all my gallons and divide by 5. So we've got to take a look at that. And so getting your calculator out is handy. We take 290 the first month plus 242 plus 196 plus 237 plus 184. That gives me 1,140. Oops, those are a little close together. It's 1,149. We said to divide that by 5 because there were 5 pieces of data. So when I divide that by 5, I get 229.8. I'm sorry, guys. 229.8 miles. Now I need to do the same thing for my gallons. So I take 12.1 plus 9.8 plus 8.2 plus 9.5 plus 7.8. It gives me 47.4. I'm going to divide that by the 5 pieces of data I have. And we get 9.48. So what I know is that I had a total of or at an average of 229.8 miles, and at an average fill up, an average gallons of 9.48. So miles and gallons. So I'm going to use that average to find my unit rate. Well, it's no different than the previous problems. We just had to find that rate. So now to find the unit rate, you're going to divide those. 229.8 divided by 9.48. And what that gives me is 24.2 miles per gallon. So beautiful. What a lovely unit rate. We're doing a lot of math here. So let's go back and look. I want to determine how many miles I can drive on a full 18-gallon tank of gas. So we've got to think about this. If I know I can do 24.2 miles in 1 gallon, how does that help me find the number of miles on 18? Well, if we go back here, we found a unit rate, we found the miles per gallon, and what that allows me to do is then multiply by the 18 gallons. And so that's exactly what I'm going to do. I'm going to take 24.2 and multiply it by 18. So 24.2 times 18 gives me 435.6. We need to think about what our units are going to be. If we go back up here and look, we were figuring how many miles. So for this one, it is just miles. It is no longer a unit rate. All right, guys, good math here going on. So you have to take a look at that in your homework tonight. Now what we're going to do is we're going to do unit analysis, which is kind of what we were doing in that last problem. But we're going to use this using the rates that we know to make a conversion. So we have 98 days that we want to convert to weeks. So whatever we're converting, we write as a fraction over 1. So if you look here, we've got 98 days over 1. What I want to do then is write a rate or a unit rate for weeks and days. But what we need to make sure of is since days is in the numerator up here, days has to be in the denominator. All right. So you have 1 unit in the numerator and 1 in the denominator. Right? I need to pause the video, pause it so everyone can get caught up with that. That's how I know to set things up. It's always going to be a multiplication problem. And so what I know is that 1 week that we're converting to has 7 days in it. The reason I do that, guys, if I have the same unit in both the numerator and denominator, I can cancel those. And so now when I look at this, I'm doing 98 times 1 and 1 times 7. Well, there's that division problem that many of you probably already knew in your head. And so if we take 98 divided by 7, we get 14, and the only unit left is weeks. So we have 14 weeks. If I need to convert weeks to days, it's the exact same process. Take what you want to convert, 15 weeks, and write it as a fraction over 1. So I have 15 weeks, notice we have to include our labels, over 1. I then have to write the ratio, the comparison of days and weeks, but this time because weeks is in the numerator, 1 week goes in my denominator. So you always have to make sure you're paying attention. It's not going to be the same fraction every time. The ratio is 7 days over 1 week. So now when I look at this, I'm going to cancel out weeks. I have 15 times 7. And so if you need to, grab your calculator. 15 times 7 is 105. 1 times 1 is just 1. And so when we look at that, we get 105. And when we look at the only units that's left is days. Okay? So that's what our unit analysis is going to look like. And some of you are probably sitting there going, Ms. Woodard, I know, divide, multiply. Great. So let's take a look on the back side now and take a look at using unit analysis for some things that we might not necessarily know right away. You have 750 United States dollars that you'd like to exchange for euros while in France. You know that the exchange rate is 0.68 euros for 1 US dollar. How many euros will you receive? So a couple important things here. We know we have US dollars that we're converting, and we know that our rate is 0.68 euros for 1 US dollar. You've got to be able to find those two things in your problem. I'm not sure how recent this information is. It's a couple of years old, so don't hold me to this. So remember, what we're going to do is we're going to set up what you're converting, what you're trying to convert, over 1. So I have 750 US dollars over 1. So I've got dollars over 1. I've got my labels. Now what I need to do is I need to set up a ratio, but I know if I have dollars here, US dollars is going to go in the denominator. So let's take a look. It says 0.68 euros. So the euros is going to go in the numerator, and that's 0.68 for 1 US dollar. Fortunately, this is a unit rate. Sometimes it could be comparing it to $2 or $3, but we know it's 0.68 euros for $1. So our dollars are going to cancel, which is what we want. We want to have euros being the only units because that's what they asked me to find. Now what am I going to do? I'm going to do exactly what the fraction says. I'm going to take 750 times 0.68. You do numerator times numerator. So 750 times 0.68 is 510. 1 times 1 is 1. That's going to give me my answer. 510 divided by 1 is just 510. Now go back and look at your problem. The only unit we had left was euros. All right. So you know what? I'll have you guys pause the video here. So give some time to get it paused. And then what I'm going to have you guys do is set this up. When your vacation in France is over, you need to exchange 215 euros you have left back to US dollars. The exchange rate is 1.46 euros for 1 US dollar. How much money will you receive? Round to the nearest cents. Like I said, pause. Try and set this up at your seats, and then I'm going to set it up. All right, so we should have had 250 euros. Our 215 euros underlined is what we want to convert. So we have 215 euros. If you use an E for that, guys, it's fine. I like to spell it all out. Over 1. It always goes over 1. And then we're converting that. We have a rate of 1.46 euros to 1 US dollar. So I've got euros here. I've got to put euros here. So notice 1.46, even though it's the first number that I have, it's not going up in my numerator. It's going down in my denominator because euros need to be opposite of euros. And then it says for 1 US dollar, so for $1. So if we take a look, these are going to cancel. I'm going to multiply numerator times numerator. 215 times 1 is 215. 1 times 1.46 is 1.46. So what I can see is that to get my answer, I'm going to divide. I'm going to divide 215. All right, we divided 215 by 1.46, and it said to round to the nearest cent. This means 2 decimal places. All right, so we have 147, and then we have 26 followed by a 0. 0 is not big enough to round it up, so it stays just 26 cents. If we go back and look at our fraction and our rate conversion, the only unit we have is dollars. So we have US, $147.26. All right, I'm going to do a quick review of percents for you guys. This is usually something we walk out of middle school really strong with. But what a percent does is it compares a part and a whole. All right, this should be just the word a. Sorry, guys. Compares a part and a whole. If you take the percent times the whole, it equals the part. So there's a way to use it solving an equation. But most of what you guys are used to looking at is over of equals percent over 100. What that means is if you compare the part over the whole, that's the rate you're going to use, that equals your percent over 100. 100 is always in your problem. The other 3 parts you'll fill out. So what number is 30% of 650? So I have 30%, so we'll have 30, and that, like we said, 100 is always going to be in there. And what we have to figure out is 650 our part or our whole? Well, we're taking 30% of 650. That's the whole part we have of that keyword helps us figure that out. So we have over 650, and then we're looking for this part. This is a fractionally, or an equation, so it's not exactly like what we had in the unit conversion. To solve these, we're going to cross multiply and then divide. So we're going to take 650 times 30. Let's see if I can move some of this stuff over. All right, so we're going to take 650 times 30, and that's 19,500, and then we're going to divide that by 100. So our answer here is 195. There's no units, so that's where we end. If we take a look at example 2, it says 15% of what amount is $36. So 15 is going to go over the 100. Our percent always goes over 100. Out of what amount? I don't know what my whole is, so that's where my X goes. And if you notice, here's the word is. So is $36 goes in the numerator. So once again, we're going to cross multiply. 36 times 100. And so that's 3,600. And then you're going to divide by the 15. So we're going to take 3,600 divided by 15. Then we get 240. We need to look and see if there were any labels because this was dollars. This is $240. The next one says 4 is what percent of 20? I don't know my percent, so this is going to be where my X goes this time. But once again, 100 is always in there. I'm taking 4 out of the 20, so hopefully you guys know to write that as 4 over 20. But once again, you've got that keyword of in there telling you to put it in the denominator. I can do 4 times 100. We're going to cross multiply, and that's 400. And then you're going to divide by the 20. So 400 divided by 20 should give me 20. What's my label going to be? Well, it says what percent. So I know I'm labeling it with 20%. And last but not least, we've got 12.5%. So 12.5. And hopefully by now you guys are getting ahead of me. You're going to put that over 100. And we want to know of what number is 192. So I don't know my what. I don't know my whole part. So there's my X. So it's looking very similar to what we had in the second example. And we've got 192. Cross multiply. 192 times 100 is 19,200. And you're going to divide that by the 12.5. So this third number you're dividing by. So 19,200 divided by 12.5 gives you 1,536. Once again, no labels. So there is our final answer. All right, ladies and gentlemen, your assignment is a book assignment, page 183, 11 through 21, 23 through 35. Remember, we move things around on the agenda, so this is what was on there for Friday. Have a good day.